We live on a water planet. 70% of the surface of our planet is water, and every living thing, including us, is made of it. Right now there are around 12,000 billion tons of it above our heads. And it's this that determines the world's weather. If you were to divide weather by the amount of people that live on the planet, this is how much we would each have. A cube of water measuring 46 meters high, wide and deep. This would be our share of the water we depend on every day, the same water we bathe in, that we drink or flush away. It's the same water that rains on us, that forms the hurricanes and the monsoons. It's the same water that's been here since the Earth was formed. Most of the world's water is locked in the ice at the poles or in the world's oceans, where it circulates through a series of currents. But there is one master current that's also the drive belt of our weather systems. It is called the thermohaline conveyor. Every ocean in the world is connected by the conveyor. It's a 70,000-mile round trip that takes about 1,000 years to complete. So how does the conveyor work? At -2 degrees Celsius, seawater begins to freeze. But this ice is made of fresh water, because salt doesn't freeze and is locked out in the process. So the water below the ice is very salty, which makes it heavier, so it sinks. As these billions of tons of cold, salty water fall, they begin to flow south. This sucks the warmer tropical waters up north to replace them. This action drives a permanent ocean cycle. From here, the route it takes is truly global. It forms the monsoons in India, twisters in the USA. But the conveyor also brings vital benefits. The water which comes out of the warm waters of the thermohaline conveyor powers the Gulf Stream in the Gulf of Mexico. The warm air the Gulf Stream brings makes the winters in Britain and Western Europe relatively mild, considering that this beach is on the same latitude as northern Canada. Despite the regulation of the conveyor, extreme weather is on the increase. Scientists are concerned that this is a result of man-made global warming. As more CO2 is pumped into the atmosphere, a blanket of pollution, increasing the heating effect, traps rays from the sun. The greatest fear is that rising temperatures will melt the polar ice, sending large amounts of cold, fresh water into the North Atlantic, where it may damage the thermohaline conveyor. If the conveyor is damaged, it could be an irreversible change, with unknown and possibly catastrophic consequences. Another concern is how even a small rise in global temperature is warming the sea, causing the water to expand. Even a fraction of a degree could mean the sea level would rise by as much as a metre. In the next 100 years, there could be as much as 42 inches of higher seas surrounding Manhattan and New York. In the most catastrophic case, Manhattan would turn into 2 islands. Combined with higher sea levels, even an ordinary storm will have drastic consequences for cities by the sea. But it's not just New York. Every city by the sea faces the same future. As the world heats up, the oceans expand, the ice will melt, and sea levels will rise. This is just one of many theories about what the changing environment will be like in the years ahead. But one thing for sure is that a warmer climate means milder weather. At the heart of these changes are our oceans. What happens to them and their system of currents will affect us all. At the end of the day, water, it seems, is indeed the key to life.